Welcome back everybody. I am a teacher from Ilm Online Academy and I welcome you to this video, and in today's video the topic is electrochemistry. This is basically the chapter number 6 of our ongoing series for the chemistry 0620, and in today's video we'll be having a look at the electrochemistry. So further ado, let's just begin and let's first answer yourself on what is electrochemistry. So we are going to start off by answering this. Electrochemistry is the branch of chemistry that deals with the relationship between electrical energy and the chemical reactions. We have two words in this, electro and chemistry. Electro is related to the electrical energy and the chemical reactions, electrical energy and the chemical reactions that we will discuss in this electrochemistry. So the basic definition of electrochemistry is that it deals with the relationship between the electrical energy and the chemical reactions, that involves the study of how chemical reactions can produce the electrical energy and how electrical energy can drive the chemical reactions. There are some key concepts that you should know about the electrochemistry first. First, you should know about electrochemical cells. So, first you should know about the electrochemical cells. This is the first one. These are the devices that convert the chemical energy into the electrical energy, and also vice versa. Opposite can also happen. So electrical energy is converted into the chemical energy, and chemical energy is converted back into the electrical energy. This is the most important of the electrochemical cell. We have different types of electrochemical cells. We have galvanic cells that generate electrical energy from chemical reactions. We have electrolytic cells. Today we'll talk about first about galvanic cell, and we'll talk about the galvanic cell and also about the electrolytic cell. These are the two types of electrochemical cells. In this chapter, we will discuss a detail about the electrolytic cell. Second, we have also the galvanic cells. In electrolytic cell, they use electrical energy to drive non-spontaneous chemical reactions. An example is the electrolysis of water to produce the hydrogen and the oxygen gases. Galvanic cells or voltaic cells, these are the cells that generate electrical energy from the spontaneous chemical reactions, and the common example of galvanic cell is the battery. And the electrolytic cell, we have the example of the electrolysis of water and also to produce the hydrogen and the oxygen gases. We have electrodes. This is the second one. We have electrodes in our electrochemistry. Electrodes, there are two types of electrodes, or the electrochemical cells have two electrodes. The first one is the anode and the second one is the cathode. Anode and cathode, these are basically made up of inert substances mostly, and the inert substances that we use for the electrodes are the mostly you can say that the graphite, platinum are most commonly used inert electrodes. Cathode attracts the cations. Cathode attract the cations that are present in our solution. Cations are positively charged. Cations will be attracted towards the cathode. So this is the hint, cations cathode, and cathode has the negative charge. Negative charge is present on the cathode, and anode is positive. It is connected to the positive terminal of the battery. It attracts the anions. Anions has the negative charge, so there is a positive negative attraction between the two different type of substances. So a simple electrolytic cell consists of the anode, that is the positive electrode and that attracts the anions. The cathode, that is the negative electrode, and cathode attract the cations. we have metals or some hydrogen that are formed at the cathode also, because metal ions are positive, that is the exception, and cathode are negative, and non-metals except hydrogen are formed at the cathode. So now we'll move towards about the electrolysis. This is the simple definition of the electrolysis. Electrolysis is the passing of a direct current through an electrolyte which is producing chemical reactions at the electrodes and decomposition of also the materials. So we have read earlier about the cathodes and the anodes, which are the electrodes. And so in electrolysis, an electric current is passed through an electrolyte. We have electrolyte. Electrolyte is the liquid solution that is present. Electrolyte is a liquid solution that is present in the electrochemical cell, and that is used to decompose any substance or any compound that is present in it. So electricity is carried out through the electrolyte by the ions which are present in the molten or in aqueous state, as the ions cannot move if it is in solid state. So we have a solution form. So in this process there is a transfer of charge occurred because of, so the transfer of charge occurs because of three more important points. The first one is movement of electrons by the movement of electrons. Second, by the loss and gain of electrons at the electrodes. Loss or gain of electrons at the electrodes. And the third one is the movement of ions in the electrolyte. So this is how the charge or the transfer of charge occurs because of this one. So movement of ions in the solution or in the electrolyte is the third one. So electrolysis is the decomposition of an ionic compound. Ionic compound is decomposed first. For example, we have an ionic compound NaCl, sodium chloride, that is decomposed. That breakdown happens when the molten or in aqueous solution by the passage of electricity or electric current is passed for the decomposition of the ionic compound between the two types of ions, positive and the negative ions. Positive ions are cations and negative ions are the anions. So electrolysis, electro means by electricity and lysis means breakdown. So lysis means the breakdown and electro means by means of electricity. So by means of electricity, the compound is decomposed or broken down into the two different ions, cations and the anions, when in molten or in aqueous solution by the passage of electricity. So this is all about the electrolysis. We have read about the electrolysis, about the electrodes, about the electrochemical cells, and also about the electrolyte, that is the substance that conducts the electricity, that is the liquid solution that is present in our electrochemical cell. Now I will show you the diagram of the electrochemical cells where electrolysis can happen. So this is the diagram of the electrolysis. Electrolysis is the passing of the electric current through an electrolyte, and electrolyte is this one. This is the electrolyte or the liquid solution that is present in the electrochemical cell or the electrochemical tank, you can call it as. So electrolysis is the decomposition of an ionic compound when molten or in aqueous solution by the passage of the electric current. This is the battery from where the current is or electric current is provided. These are the electrodes. Electrodes are made up of mostly inert substances, platinum maybe, or you can use platinum for the electrodes, and also we have some more inert substances like graphite, carbon. All these can be used for this one. Next, cathode has the negative charge. Negative charge is present on the cathode because it is connected to the negative terminal of the battery, and anode has the positive charge because it is connected to the positive terminal of the battery, as you can see on my screen. So The passage of electric current is like that, how the current flows from the battery. From the negative terminal of the battery, electrons move towards the cathode. Electrons are present in the cathode, and this is how the electric current is moved from negative terminal towards the positive terminal of the battery. In our electrolyte, we have positive and negative ions. Positive ions are attracted towards the cathode. When they are attracted towards them, what will happen? As cathode has negative electrons, so these negative electrons are taken by the positive ions and they become deposited on the cathode for becoming the neutral substances. For example, if we have sodium ions, as you know that sodium has the positive charge, so when sodium move towards the cathode, what will happen? A redox reaction happens here. Redox reaction happens there. So in the redox reaction or the oxidation reduction reaction, electrochemistry is based on these type of reactions. Electrons are transferred between different species. Oxidation involves the loss of electrons, while reduction involves the gain of electrons. So here at the cathode, electrons are gained by the sodium atoms. Sodium will gain that electron and forms the neutral sodium metal like this. Suppose, for example, if we take the example of sodium chloride. So electrons are taken by the positive ions or the cations, and when negative ions are attracted towards the anions, anions are attracted towards the anode, then they give the electron because they have more electrons in their structure as compared to the protons. So chloride ions, as we talk about the chloride ions, when they attracted towards the anode, they give the electrons and becomes the neutral like this one. So electrons are moved from negative towards the positive terminal of the battery. So this is how the electrolysis happen, and the breakdown of the ionic compound results in the cations and the anions that are formed into the solution. So this is the electrolysis of any compound that happens. We have electrodes, we have electrolyte, that is the liquid solution, and the battery is also present there for the conduction of the charge. So the transfer of charge during the electrolysis is by the movement of electrons. The first one is by the movement of electrons into the external circuit. Electrons are not present in the electrolyte, they just move into the external circuit. There is a loss or gain of electrons at the electrodes. So the transfer of charge happens here. And last one is the movement of ions into the electrolyte solution that represent the liquid solution. So these are the three important possible situations where the transfer of charge happens. So during the electrolysis, metals and hydrogen ions are formed at the cathode because metals have positive charge, and hydrogen ions are deposited or formed at the cathode, and non-metals are mostly formed at the anode. So non-metals mostly have the negative charge, so they are attracted towards the anode because anode has the positive charge. Next, we will talk about the electroplating. Metals are mostly electroplated. Why metals are electroplated? To improve their appearance and also the resistance to the corrosion. That's why metals are electroplated. First reason is about to protect them or to make them as the resistant to the corrosion, and second is improve their appearance. So this is how or why the metals are electroplated. So first you should know about metals are electroplated by, we have some rules or steps through which metals are electroplated. The first one is place an object at the cathode. We have to place object at cathode, the object to be electroplated. This is the object that is to be electroplated. That object is placed at the cathode. The second one, place the pure metal at the anode. Pure metal is placed at anode. Mostly we have the sheet or the rod of the pure metal that is to be placed at the anode. The metal will coat the object at the cathode. This is the metal to coat the object at the cathode. And the third one, electrolyte, is the aqueous solution of the solute or the soluble salt of the pure metal at the anode. And at the anode, metal loses the electrons and form the ion in the solution, and at the cathode it gains the electrons because atoms that deposit on the object, thus electroplating it. So these are the three rules, and the third one is about the electrolyte, the aqueous solution of the soluble salt. Electroplating is used to make the metals resistant to the corrosion and also to improve their appearance. That's why we done the electroplating. So next we'll talk about also about identifying the products that are formed into the electrolysis. So now we have the binary compound in the molten state. Binary compounds are those that contain two elements, as binary means two. So two elements are chemically combined. For example, in the example of the binary compounds, we have lead bromide. To carry out the electrolysis of lead bromide, we first need to melt it, since it is an ionic compound, and ionic compounds conduct electricity in solution form or in molten state, not in the solid form. So we use an electrolytic cell like this, as you can see here, for the electrolysis of the lead bromide. So we have solid lead bromide, which is now melting. This is the molten lead bromide. We don't add any type of solution or liquid in this. We just heat it and convert it into the melting because of the heat that is applied. So it is now melting. Heat is applied to melt the lead bromide. We have cathode and we have anode. Anode is connected to the positive terminal of the battery and cathode is connected to the negative terminal of the battery. Cathode is the negative electrode and anode is the positive electrode. So we have this is the lamp. So I think we should discuss about this also. This is the lamp. When the current is passed or when the electricity is passed through the wires, the lamp will turn on, and when the lead bromide is molten. So electrolytic cell showing the electrolysis of lead bromide is there. So we have the binary compound electrolysis or binary compound in the molten form. So what will happen here? We have Pb Br2, which is the lead bromide, which is in molten state in our electrolytic tank. In this process we have two types of reactions that will happen here. First of all, I'm sharing you about the equation. Lead bromide, when it is converted into the molten form, it converts into two types of Br2 as the bromine, plus we have lead that is in liquid form. Lead is in liquid form and bromine is present in the gaseous form because bromine is a gas. So we have two types of reactions that happens in the electrolysis. First is the oxidation and second one is the reduction. Oxidation is the loss of electrons, that happens, and the second process is the reduction, is the gain of electrons. Reduction is the gain of electrons and oxidation is the loss of electrons. Reduction is the process in which the molecule gains electrons, and oxidation is opposite to the reduction in which the atom loses the electrons. So these are the two reactions or redox reactions that happens in the electrolysis. So for the electrolysis of the lead bromide, what will happen? We have molten lead in our solution and the bromine gas is present there. So in this process, lead ions are reduced to the lead atom, and therefore I will show you here the ionic equations that happens here. First of all, lead ions are reduced that are present in the liquid form. Lead ions, lead Pb2 positive that is present in the liquid form, is attracted towards the cathode. Here the lead ions that are present there are attracted towards the cathode electrode, because cathode has a negative charge. Electrons are present in this electrode, so lead will reduce to the lead atom by the gaining of the electrons like 2e negative. So this is the half ionic equation for the cathode electrode. The lead metal is deposited at the cathode. Since it is a cation, so it has the positive charge. So you can see here near the cathode we have the molten lead that is present there. So this is the reduction or the gaining of electrons that happens at the lead, that happens at the cathode electron, and this is the first half ionic equation that happens in our electrolysis of the lead bromide. Next we'll talk about the electrolysis of the bromide ions. Bromide ion loses the electrons, Br negative. Bromide ions are also present in the liquid form, so bromide ions loses the electrons to become stable and become the bromine atoms like this one. The two bromine atoms combine to form a bromine molecule because the single atom of bromine is unstable. So bromide ions are oxidized, in this they lose the electrons. So during this process we have two bromine atoms, Br plus Br, they form the bromine gas Br2. And this is the bromine gas that is produced at the anode, and it gives the electrons to the anode, and those electrons are moved towards the battery. So this is how orange red gas is produced at the anode, that is the bromine. And you will notice that lead is being formed at the cathode and bromine gas is being formed at the anode because of the opposite charges that are present on it. So this is how the electrolysis of lead bromide happens in the electrolytic cell. We have two electrodes. We have the electrolyte, that is this liquid solution, or you can say that we have the molten lead bromide. In this case, that molten lead bromide is converted into the liquid state by applying the heat. So when the electric current is provided, what will happen? Lead ions are moved towards the cathode because lead ions have positive charge and cathode has the negative charge, and bromine gas will move towards, or bromine gas is formed at the anode because of the negative charge that is present on it, and positive negative attract each other. So this is how the electrolysis of bromide ions and the electrolysis of lead ions occur in the electrolysis of lead bromide. Now we'll discuss the electrolysis of the aluminum oxide. Electrolysis of aluminum oxide is a process that uses electricity to extract the aluminum from the aluminum oxide ore. So for the electrolysis we have the ore of the aluminum oxide, that is known as bauxite. Bauxite is the ore of aluminum oxide. First step is to purify the bauxite from the aluminum oxide, and the second step is that to dissolve this aluminum oxide into a molten cryolite. First we have the aluminum oxide ore, that is known as bauxite, and that is dissolved in the cryolite just to reduce the melting point of aluminum oxide. The melting point of aluminum oxide is over 2000 degrees Celsius, so it is dissolved in the molten cryolite, which is an aluminum compound with a lower melting point. So just to reduce the melting point of aluminum oxide, we dissolve the cryolite with the aluminum oxide. So then we set up the electrolysis cell. You can see here on my screen, the mixture is placed in the steel electrolysis cell that is lined with the graphite. This is the steel tank that is lined with the graphite as an inert substance. The graphite lining acts as a negative electrode and the large graphite block acts as the positive electrode. These are the large graphite electrodes that acts as the anode. As you can see here, the positive charge is present there, so these are the anode electrodes. So first it is treated with or dissolved in the cryolite just to reduce the melting point of aluminum oxide. The melting point of aluminum oxide is over 2000 degrees Celsius. Then it is reduced the melting point of pure aluminum oxide to about 1800 to 1000 degrees Celsius between. So this the electrolytic cell is used for the process of electrolysis of the aluminum oxide. During this process we have two types of ions are produced. First we have, as the formula, Al2O3, we have aluminum oxide. Aluminum ions are produced and oxide ions are produced. In this, oxide ions are oxidized and aluminum ions are reduced, and the half ionic equations for both of these will be like this. So now I am here to show you. As you can see here in this diagram, we have aluminum oxide that is dissolved in the cryolite and that is present in this electrolytic cell. We have carbon or graphite electrodes, anode and the cathode. Cathode is the lining of the electrolytic tank, and cathode are present in the suspended form. They are connected to the negative and positive terminal of the battery. And we have the molten aluminum, which is produced after the electrolysis, and they are collected from here. Molten aluminum metal is collected from this point. So the half ionic equations, during this process when electricity is provided, what will happen? The aluminum oxide is converted into the ions, and those ions are aluminum ions, plus we have oxide ions. Oxygen is released. So 4 aluminum ions are released here when we use 2 molecules of aluminum oxide, and 3 molecules of oxygen gas is released at the electrodes. So the half ionic equations for both of these are given here, which I will show you. When we provide the electricity, the aluminum oxide or the compound, that is it, will break down into the 2 ions, aluminum and the oxygen. So we have aluminum ions which has positive 3 charge that are present in the solution, and they take 3 electrons from the cathode, and when they took those electrons to become stable, that is the aluminum, and it is present in the liquid form. So it is present in our electrolytic tank above the lining of the cathode electrode, from where we have a point from where molten aluminum is collected from here. The next ionic equation of the oxide ions, which are oxidized, we have oxide ions O2 negative. So when these are oxidized, they form the oxygen gas and release 4 electrons. 2 electrons are released from one oxygen atom and 2 electrons are released from the other oxygen atoms. So when 2 oxygen atoms are oxidized, they form the oxygen gas, which is the stable one, and release 4 electrons at the anode, which are moved towards the positive terminal of the battery. So oxygen gas is being produced, and since the electrodes are made up of carbon or graphite, which is a form of carbon, so the oxygen reacts with the carbon and produce, as the electrodes are made up of carbon and graphite, graphite is also a form of carbon, so oxygen reacts with the carbon that is present at the electrode and form carbon dioxide, which is CO2, like this, as it is enough activation energy for the reaction to occur just because of due to the temperature of the cells. So this means the graphite anode will have to be replaced and it will burn away, as because oxygen reacts with the carbon and form the carbon dioxide. Only anode, because the oxygen will be formed anode and not the cathode. So anode is replaced quickly, or will be replaced as it will burn away. So this is how the electrolysis of the aluminum oxide happens in the electrolytic tank. We have this electrolytic tank, and the overall equation for this one is aluminum oxide that produces aluminum metal plus the oxygen gas, and that oxygen gas will react with the carbon to form the carbon dioxide gas. So this is the electrolysis of the aluminum oxide that happens in the electrolytic tank. Next we'll talk about the electrolysis of concentrated aqueous sodium chloride. Concentrated aqueous sodium chloride is a strong saltwater solution with a high amount of salt or sodium chloride that is dissolved in the water. So this is the apparatus or the electrolytic cell through which we have the electrolysis of the concentrated aqueous sodium chloride. Since sodium chloride is an ionic compound, so we have to dissolve it in the water for the conduction of the electricity, because in solid state ions are present in fixed form and they do not conduct the electricity. So by doing this, ions in the sodium chloride dissociate into the water. There are 4 ions in the solutions. We have hydrogen ions and hydroxide ions because of water, or that are formed from the water. We have sodium ions, and we have chloride ions that are formed from the sodium chloride NaCl. So these are the 4 types of ions that are present in the solution. When the current flows, the hydrogen ions and the sodium ions are both attracted towards the cathode. We have sodium ions, these are the sodium ions, and also the hydrogen ions when they are present in the solution. This is the diagram for the molten NaCl, and this one, as you can see here under this is for the concentrated aqueous solution of the sodium chloride. We have in the solution, we have sodium and chloride ions that are present there. So sodium ions are attracted towards the cathode and chloride ions are attracted towards the anode. So chlorine gas is being formed at the anode and sodium is deposited on the cathode. But in the solution of the concentrated aqueous solution of sodium chloride, we have hydrogen ions, hydroxide ions, sodium ions, and chloride ions that are present there. So sodium ions has positive charge, they are attracted towards the cathode. Hydrogen ions are also attracted towards the cathode. Hydroxide ions and chloride ions are attracted towards the anode. So they both are attracted towards the opposite electrodes, but as the hydrogen has the stronger electrostatic forces, so it accepts the electron more easily than the sodium ions. That is why hydrogen gas is produced at the cathode instead of the sodium metals. So the reaction that happens here at the cathode, 2 hydrogen ions will take the electrons from the cathode and form the hydrogen gas, because hydrogen gas has strong electrostatic forces, so it accepts electron more easily. Again, both hydroxide ions and chlorine ions are attracted towards the anode. The chloride ions lose the electrons more easily as they have weaker electrostatic forces due to more number of shells that are present in their structure, and chlorine gas is formed at the anode. So we have the reaction of the chlorine gas that happens at the anode, Cl2 plus 2E negative. So these are the 2 reactions that happen for the electrolysis of the concentrated sodium chloride. And this is the movement and discharge of the ions in the electrolysis of concentrated sodium chloride. So this is how at the cathode hydrogen ions accept the electrons, and at the anode we have chloride ions that are present there. So this is the electrolysis of the concentrated solution of the sodium chloride. We have half equations are present there, and now I will show you the overall ionic equation for this one. The overall ionic equation for the concentrated aqueous solution of sodium chloride will be, we have NaCl, 2 NaCl plus 2 water molecules react together and they form 2 NaOH plus H2 gas that is formed at the cathode and Cl2 gas that is formed at the anode. So the ions that are not that are present in our solution, those are the sodium ions and the hydroxide ions. So hydrogen ions will take electrons more easily or more quickly from the cathode as compared to the sodium ions. So sodium ions will be attracted towards the hydroxide ions that are present in the solution. So the effect of the concentration is important. Electrolysis of the dilute solution of sodium chloride results in the formation of oxygen gas at the anode rather than chlorine, and when the concentration of chloride ions is low, it is hydroxide ions that are discharged instead. So hydrogen is still produced at the cathode. These results indicate that the discharge of chloride ions ahead of hydroxide ions only applies if the concentration of chloride ions is sufficiently high. So we have some electrolyte solutions, and I have shown you the overall reactions of the sodium and the hydroxide ions that are left behind in the solution. This is how the sodium hydroxide forms, just because of the left ions are left in the solution, and the solution therefore becomes the alkaline. Just because of the presence of NaOH, the solution becomes alkaline, and this can be shown by adding the any indicator to the solution. We mostly use the universal indicator, or that term the purple, as the electrolysis take place, and the overall reaction for the electrolysis is here when we use a concentrated sodium chloride. Now I have a summary for the difference in the products that are formed for the concentrated and the dilute solution of the metal halides. For example, if you have concentrated NaCl, then what will happen? So concentrated aqueous solution of NaCl produces two products at the cathode and the anode. The first, at the cathode, we have hydrogen that is produced at the cathode because of the electrostatic forces. So it depends upon the electrostatic forces which ion will be attracted or which ion will take the electrons from the cathode. Hydrogen has more electrostatic forces, so hydrogen will take as compared to the sodium. And chlorine gas has weaker electrostatic forces, so chlorine it will be easy for the chlorine to give the electrons as compared to the hydroxide ions that are present in the solution. And next we have concentrated solution of potassium bromide. This is also aqueous, and it produces also hydrogen at the cathode, and bromine is produced at the anode. Next we have dilute solution of NaCl. This is also aqueous solution, and this solution produces hydrogen at the cathode and oxygen at the anode. Just because of that, the difference is in the concentration of chloride ion is sufficiently high, then these results will be indicate that the discharge of chloride ions ahead of hydroxide ions, right? So in case of dilute solution, we have less chloride ions that are present there, so oxygen will be present at the anode, or oxygen is formed at the anode. And also in dilute solution of KBr, which is also the aqueous solution, and in that we have also hydrogen at the cathode and oxygen is formed at the anode. So this is for further information on the nature of the electrode reactions can be found. We can done the experiments by using different type of salt solutions. And now next we will talk about the electrolysis of dilute sulfuric acid. So this is the apparatus for the electrolysis of the dilute sulfuric acid. This is a Hofmann voltmeter that is used here for the electrolysis of dilute sulfuric acid. Although water is a very poor conductor of electricity, it can be made to decompose if the water is acidified with a few drops of sulfuric acid. So we have an electrolytic cell such as the one shown here, which is the Hofmann voltmeter, that can be used for the electrolysis of dilute sulfuric acid, as it keeps the gases produced as separate. So you can see here we have the battery power supply that is present at the bottom, and next we have platinum electrodes that are present there. Anode and cathode are made up of platinum. We have hydrogen gas that is produced at the cathode, and oxygen gas is produced at the anode. So this is the electrolysis of dilute sulfuric acid. So what will happen here? Water is present there. Water is added to this one, or acidified water. A few drops of sulfuric acid is present in the water. Batteries DC supply is also connected to this to enable the water to conduct electricity. This dilute sulfuric acid or sodium hydroxide solution is added, but in this we are adding some drops of dilute sulfuric acid in this one. So when the power is turned on, gases are seen to be produced at both the electrodes. Bubbles are produced. Bubbles show that the indication of the gas that is formed at the cathode and the anode. In this we have oxygen gas and the hydrogen gas. So by the formation of the bubbles, you can easily see the formation of the hydrogen gas and the oxygen gas. Twice as much gas is produced at the cathode than the anode. The gas at the cathode burns with a pop, proving that it's a hydrogen gas. So there is a specific sound for the production of the hydrogen gas, a squeaky pop sound. So in this process, a positively charged hydrogen ions are moved towards the cathode. So when hydrogen ions are moved towards the cathode, what will happen? As they will take electrons from the cathode and forms the hydrogen gas like this. When one hydrogen ion moves towards, it will take one electron from the cathode and forms the hydrogen atom. As hydrogen atom is unstable, so it will form the hydrogen gas. The gas is collected at the anode and it can relight a glowing sprint, proving to be a oxygen. So squeaky pop sound in case of hydrogen, and a glowing splinter is produced, or the indication of the production of the oxygen gas at the anode. Oxide ions are moved towards the anode, and when they move towards, they give the electrons. When they give the electrons, we have water that is produced plus oxygen gas plus electrons are given at the electrons cathode or anode. So this is how the reactions happen at the cathode and at the anode. At the cathode we have hydrogen ions, and at the anode we have hydroxide ions that are moved towards the anode, and they give the electrons to the anode electrode, and by giving that electrodes they form the oxygen gas. Glowing splinter will be produced, and that proves that it's a oxygen. So inert anode, chlorine, bromine and iodine are all the halogens that are preferred over the oxygen, and inert cathode, hydrogen is preferred over the metals unless an unreactive metal is present. So this is how the electrolysis of the dilute sulfuric acid happens at the Hofmann voltmeter, where we have water with a few drops of sulfuric acid is added, and when we add the water, what will happen? We have the half equations for the reactions that have taken place at the two electrodes. Hydrogen ions are moved towards the cathode and hydroxide ions are moved towards the anode, and they are formed at the respective electrodes. Electrolysis began to show that some ions are discharged ahead of the other during the electrolysis. So the overall reaction will be, for the overall reaction for the electrolysis of water or acidified water will be H2O that produce hydrogen gas plus oxygen gas. As this one is not balanced, so you can balance it by putting the 2 in the coefficient with the water and also with the hydrogen gas. So this is how the electrolysis of the dilute sulfuric acid will happen. So now we'll do the electrolysis of copper sulfate. This is the diagram for the electrolytic cell for the electrolysis of copper sulfate solution. Copper is a very poor conductor. No, copper is a very good conductor of electricity and heat. So even small amounts of impurities can affect this conductivity noticeably, whether in the fine wires or in the large cables. So to ensure the purity or newly extracted copper, it has to be purified by the process of electrolysis. So the impure copper is used as a anode and the cathode is made from the pure copper. As you can see here, we have the cathode and the anode. This is the anode electrode, sorry. So this one is the anode electrode, and we have impure anode that is present there, and a pure copper or cathode which is made up of pure copper will be there. Any impurities fall to the bottom of the cell and can be collected below the anode. This usually consists of the precious metals like maybe gold, silver, anything like that. So we have the electrolyte solution of copper sulfate that is present in the electrolytic cell. So we have half ionic equations that happen at the cathode and anode will be, at the cathode what will happen, we have at the cathode and at the anode. From the anode, because anode is made up of impure copper, so the copper ions are removed from the, or copper is removed from the anode electrode, because there is also some impurity that is present there, and that copper will move towards the cathode, and copper is deposited at the cathode, and this is the reaction that happens at the anode. And at the cathode we have copper ions that are present there, and they took the electrons from the cathode and formed the copper metal. So you can see here at the anode what will happen, the copper is removed. When copper, how copper is removed, copper gives the electrons to the anode and forms the cations, and then these are present in the solution. Those copper ions are attracted towards the cathode and they are deposited at the cathode by taking the electrons from the cathode or the negative electrode. So this is how you can see here how the purification of the copper happens. This is also, you can say that the electroplating process. This is the process of electrolysis in which the metal object is coated with the layer of another object. Electroplating is a process. Electroplating is the process in which one metal is plated or coated with another just to improve the appearance and also to give the protective coating. For example, if we talk about for the electrolysis or for the electroplating, silver electroplating that is done for most of the metals. So for silver electroplating, electrolyte is a solution of silver salt. We use the electrolyte of that specific type. Electrolyte is of silver salt. Any silver salt can be used as an electrolyte, and the item to be plated is made the cathode in the cell so that the metal ions move to it when the current is switched on. For example, we have silver ions that are present there, and they take the electrons from the cathode and forms the metal as the silver. So this is how the electroplating of any metal can be done here with the process of electrolysis. Electrolysis or electroplating, electrolytic cell is adapted from the type usually used. The cathode is the object to be plated and anode is made from the metal that is being used to plate the object. For example, we have a silver nitrate solution, silver salt any used, so silver nitrate solution that is present, and this is the cell for the electroplating with the silver. We have the anode, this is the battery, and this one is the anode. We have a solution of silver nitrate, any silver salt can be used, and we have the object metal. This is the metal spoon that acts as a cathode because it is to be electroplated. So electroplating can be used to coat one metal with another, anode is made up of silver and it has a positive charge. That silver is deposited or electroplated on the silver spoon that is present there at the cathode. So this is how the electrolysis, or electroplating is done with the silver. This is how the electroplating is silver is done from the anode. Anode is made up of silver and that is to be electroplated on the cathode. We use the object on the cathode as to be electroplated. Object to be plated must be at the cathode, and the electrolyte must be a solution of the salt of a metal to be plated on the object, and the anode is made up of the strip of metal to be plated on that object, like the silver, because silver is to be plated on the spoon that is present at the cathode electrode. Next, we will talk about the hydrogen-oxygen fuel cells, or hydrogen as a fuel. A hydrogen-oxygen fuel cells uses only hydrogen and oxygen to produce the electricity, with the water as only the product that is produced here in this. In electrolysis, we put the electrical energy to make a chemical reaction to happen. The reaction that takes place is always a decomposition reaction in which a breakdown happens of the compound. The change is endothermic. Electrical energy is put into to bring about the change. Endothermic and the exothermic process were introduced in the first chapter and will be discussed further in the 7th chapter. So it is possible to reverse this process and uses the chemical reactions to produce the electrical energy. This is what take place in the electrochemical cells and the batteries that we often use in our everyday situations. So simple electrochemical cells can lose their power and need to be recharged from time to time, and many of the substances found in the electrochemical cells are harmful and difficult to dispose of. So a much more efficient way of changing chemical energy into electrical energy is by using this fuel cell. Such a cell operates continuously with no need of recharging. The cell supplies energy as long as the reactants are fed into the electrodes, and hydrogen-oxygen fuel cell uses the reaction between the hydrogen and the oxygen. Hydrogen gas plus oxygen gas react together to form the water. So we'll balance this equation like this. This releases a large amount of energy. Water is the only product. Hydrogen can be regarded as the non-polluting fuel in this one. So we have a fuel cell, that device for continuously converting chemical energy into electrical energy by using a combustion reaction. A hydrogen fuel cell uses the reaction between the hydrogen and oxygen, and the fuel is a substance that can be used as a source of energy. So this is how you can use hydrogen oxygen fuel cells, that uses hydrogen and oxygen to produce the electricity with the water as the only chemical product. So we have also some advantages and disadvantages of using hydrogen oxygen fuel cells rather than gasoline petrol vehicles. So these are the advantages of the hydrogen oxygen fuel cells. The first one is that it does not produce pollution. It uses hydrogen and oxygen to make the non-polluting water while generating electricity, compared to the petrol engines, which produce more, and many pollutants are produced in case of gasoline petrol engines. So similar to the battery, but no external charging is required in case of hydrogen oxygen fuel cells, and it releases more energy. Third one, no power loss happens there. This is the capable of producing electricity as long as hydrogen and oxygen are supplied. So it releases more energy, no power lost in this, and it does not produce any pollution. These are the advantages that are present in case of hydrogen oxygen fuel cells. And the last one, these are more quieter and less noise pollution are produced. Because of hydrogen oxygen fuel cells. The last one, we will talk about the disadvantages now. The disadvantages related to hydrogen oxygen fuel cells are: they are expensive as compared to the traditional ones, the gasoline petrol vehicles, and the fuel cells are expensive. They are difficult and expensive to store. difficult to store them. Hydrogen is difficult to store in a car as it is a gas at the room temperature, right? So fuel cells are very expensive right now at this moment, and they are difficult to store. This is the second one. And the third one, fuel cells are affected by the low temperatures, so they are less efficient. Less efficient because they are affected by the low temperatures, and electric motors and fuel cells are less durable than the petrol or the diesel engines. There is no existing infrastructure for refueling stations for this one. This is also the disadvantage, and the last disadvantage will be less hydrogen filling stations. Right now we have less hydrogen filling stations for this one. So these are the disadvantages related to the hydrogen oxygen fuel cells. Hydrogen is difficult to store in a car as it is a gas in a room temperature. There are no existing infrastructure or refueling stations for this one. And the next one, electric motors and the fuel cells are less durable than the petrol or the diesel engines, and fuel cells are very expensive at this moment right now. So these are the advantages and disadvantages related to the hydrogen and oxygen fuel cells. We have advantages and disadvantages as an alternative to the petrol engines in the vehicles. So the last one is about hydrogen oxygen fuel cells can be used to generate the electricity from the reaction between the hydrogen and oxygen with the water only as a byproduct. So this is all about today about chapter number 6, which is about the electrochemistry. So we are done with that, and hope you understand all. We'll meet in the next video.